In the previous video, I've covered a feature, spanning tree feature called port fast. Then I covered the uplink fast. So uplink fast is very similar to backbone fast I'm about to explain, but the uplink fast feature is basically the reaction of a switch when there is a root port and an alternate port, and we lose the root port. So this port, instead of waiting max H time 20 seconds, then forward delay listening 15 seconds, forward delay learning 15 seconds, it opens the port immediately for transmission. Backbone fast is very similar, however, it determines that there was an indirect failure in the network. So what is happening, let's say, without backbone fast in this particular picture? We have a root bridge because it has the lowest MAC address. The priority on all switches is the same, so the tiebreaker to select the root bridge is lowest MAC addresses, which is AABBCC0011. This is 12, 13, and 14. So Rootbridge is now sending BPDUs everywhere, introducing itself, and it introduces the cost to itself, which is cost is equal 0. So cost is equal 0. Now this guy adds the cost of 100 here on this interface, so the total cost here will be 100. And during the listening stage, so there's nothing elected yet. No, there's no. The only thing we know is the root bridge is 1-1, and all designated ports are sending hellos. Now this port is receiving cost 0, adds a port cost, so it is going to be 100 here total cost. Now we pass this BPD frame saying, hey, 1-1 is my name is 1311 is sending BPDU. My best path to the guy is 100 is advertised. Whoops. And when that happens, this guy adds the local cost of the port, which is 100. So total cost is going to be now 200. So the total cost here is 200 in this direction. Total cost is 200. It receives also the cost advertised here. Hey, my cost is 100 towards the root bridge. There's a local cost of the port 100 here. So the total cost is going to be here in this direction 200. So the tiebreaker is going to be a lowest MAC address of the sender, or lowest bridge ID, I should say, of a sender. Since priority is the same, the tiebreaker is 1-1 is better than 1-3. So 1-2 is 1-3 versus 1-3. This guy is going to be the root port. In this particular situation, cost 100 and advertise 200, adding cost of this port is actually now received. The total cost will be 300. So it's 100, 100, 100. That is a total cost of 300. So 100 is better. So the cost is actually tiebreaker, the first thing. Once the root ports are selected, we still need to kind of, let's just go to remove that. We need to basically now consider this loop. So root ports will be open, root port will be open, but there's a loop here still created. How does it handle that? It thinks, okay, this is 100 plus 100, 200 cost. 100 plus 100, 200 is the cost. Okay, tiebreaker is the next step, is the lowest bridge ID. Priority are the same. Priorities are the same on both, but this is a 1-3 MAC address, 1-2 MAC address. This one is worse than this one, so this is going to be the root port. And the last step is to remove the loop. So since the port is now, either this port will be designated on switch 3 or on switch 4. Which one? When this guy is advertising, its cost now is 100 plus 100. This switch advertised BPDU towards the root bridge cost is 100 plus 100, the same cost. This switch has a 1-4 MAC address. This switch has 1-3 MAC address. 1-3 is lower than 1-4. This goes as an alternate port and it goes blocking. So at this point, it is selection of the loop-free topology is complete. What happens now, this is where backbone fast comes into play, is that backbone fast allows quicker reconvergence and skipping the max H time, the blocking state, 20 seconds. So it's still going to go through listening 15 and learning 15 seconds. But it is all about indirect failure. So what I mean is this. What happens if this port goes down? All of a sudden, the switch 2 is no longer receiving BPDUs. Now, out of the root ports, we're not sending anything. Out of the blocking port, we're not sending anything, not learning anything. Here we're learning MAC addresses, but we're not sending BPDUs up there. So switch 2 thinks, oh, I am a new root bridge because I lost the root bridge, so I must be the one. I am root. Now switch 4 is receiving conflicting information. So 1, 2 MAC addresses, I'm the root bridge. Here we are still receiving and processing on the block ports. We are processing BPDUs. And this guy says, I am a root. My name is my MAC address is 11. I am root. And it knows who's the winner. It knows that this path and 11 is the root bridge. But it won't tell this guy anything at this point because this port is in a blocking state. The selection process is not happening just yet. So when that happens, there's this max H time 20 seconds before this goes listen, and this goes up here says, okay, listen, the root bridge is 11. You're not the root bridge. So let's see that happen on the command line interface. So what I'm going to do, I'm going to shut down the E40 interface on switch 2 with the debug on switch 4. So I'm going to go to switch 4 real quick. So conf-d, actually debug spanning tree events. Okay. So I'm enabling debug spanning tree events here, and I'm going to shut down on port 2, root port, which is here, this port, E40, conf-d. So without backbone fast, interface E40, and shut. Let's quickly jump to switch 4. It's already receiving information from 1, 2. Hey, I am a new root bridge. I'm a new root bridge. And the max time must expire before this port goes listen. The port here goes listen and starts, re-election of the topology or recomputation of the topology. So now we're gonna go listening, and now at this point this guy stops sending I am the root because it already received information. No, you're not. The root bridge is 1-1 still. Goes learning 15 seconds, and the total delay will be before the loop-free topology is elected or selected is going to be 50 seconds. We can make that better. So let me just go back here and bring this port back up. So this is gonna quickly go back to what it was. And what I'm going to do is I am going to enable on all switches spanning tree backbone fast. So what is going to happen is that instead of waiting max H time here 20 seconds before we notify switch 2 that it is not the root bridge, new root bridge, we'll do this immediately. So we'll skip that max H time and we'll just go listen, learn, and then forward. So let's see that happen. So what I'm going to do is I am going to, on all switches, in a global config mode, spanning tree backbone fast, real quick, and spanning tree backbone fast, and spanning tree here, backbone fast, and spanning tree backbone fast. So debug is still on. I'm going to do one more debug, spanning tree backbone fast. I'm also enable apart from show spanning tree, actually show debug. I am already running the backbone fast, spanning tree backbone fast and events. So what is going to happen now? What I want to show you real quick, if I go back to E40 and shut this down, quickly jump to switch 4. And we just heard this one message from, hey, I'm a root bridge, and the port goes listening and sends, no, you're not. Before that happened, though, what happened before that was the switch 4 sends, that's why I enabled in the second debug, send this out this 40 root link query. So when it received, hey, I'm a root bridge, it wants to be sure that the old one is still available before it notifies switch 2 that the root bridge is still 1.1. So it sent this root link query request on its port E40. Hey, is there a root still out there with AABBCC1100? Yes or no? This guy sent the response, so we received the response from the root bridge on the same port. And then we can notify this guy, hey, you're not the root bridge. The 1.1 is the root bridge in the network. Ports go listening 15 seconds, learning 15 seconds, and this way Backbone Fast shaves off 20-second max age time. Without Backbone Fast, we would wait 50 seconds for reconvergence to occur. In the next video, I'm going to cover a few other features like BPDU filtering, BPDU guard, and the root guard.